All right, welcome back everybody to Data Programming 1. First, as I get started, today we're going to need the worksheet from the web page. We're going to be using Jupyter Notebook, and we're going to be using IDLE. So if you're watching the live stream, you can go ahead and open all those up while I'm going over the announcements. Otherwise, when the time comes, you can just pause the video and pull those up yourself. All right, a couple things. First, thank you for all the messages. I'm back. I still don't know what's wrong. I had chest pain a week ago Sunday. Ended up in the emergency room. This afternoon I have more tests. They're doing an electrocardiogram and a heart stress test. So I won't be there for office hours. Those will resume tomorrow for me. I apologize for those of you guys who need to come see me. And again, thank you for all the messages wishing me well. I really appreciate them. All right, a couple of just thoughts on course logistics. We do have a partner matching form if you're looking for a partner beginning for the next project. It's coming out Wednesday. The projects get longer as we go through the semester, and near the end of the semester, the projects can take up to 8 hours per week for students who've been from past semesters. So the partner matching form is going to be there for anyone who's looking to connect with a new partner. We fill out the form. We'll send you the contact info of someone who we feel would be a good match for you. If it works out, that's awesome. You can contact them. If not, feel free to fill out the form again and we'll suggest someone else. So find someone that you enjoy working with who makes you learn better. All right, we also have a thank you form in a class this big. In fact, let me pull these up right now. Here we go. So these forms are available under resources on our tools on our webpage, tools, class surveys. The partner matching form is number 6. The thank you form, if you find that a TA has been particularly helpful, if you've been to office hours, there's over 800 students in the class. So if you find that a TA has been particularly helpful, a lot of times this can feel like a thankless job. We want to let them know that they're doing a good job and that their work is appreciated. So go ahead and fill that out if someone helped you and you were particularly excited about what happened. All right, next up, our first exam is on Friday. Now, Mina sent an email with all the details. I'm not going to go over those here. But people often ask me, what is the best way to study for that exam? In particular, for an online exam, this might be, it's probably not the first online exam you've taken, but it might be one of the first. So I highly recommend going to, let's see where resources, our old exams are right here. Under exam 1, you can find all the exams we've given for the past several semesters. Go ahead, take a look at those. Now, I want to stress that all of those exams were given in person. You would go to the classroom, you didn't have access to Python or the internet or anything that, all the lecture material, the PowerPoint slides, the worksheets. All of those were just taken on Scantron with a pencil and paper. So the questions we're going to be asking in those exams are a lot of the time, here's some code. What does it print out? Obviously, we'll be changing the structure of those questions because any question you could copy and paste into Python and just run, you don't actually have to understand what's going on in order to get the answer. So it doesn't work well for us. It doesn't demonstrate that you understand what's going on. So the type of questions will be changing a little bit, and you will have access to the internet. You will have access to all your notes. The only thing you may not do is talk to another person. That means any person, whether it's online, in person, asking questions on Piazza or Chegg. We check all that stuff. And as of right now, we're not going to be using any sort of online proctoring tool. Let's face it, HonorLock is pretty invasive. I do not want to see a 360-degree rotation of your room. I don't want to know every time your roommate walks past in the background. So until we find evidence that anybody is using Chegg or Piazza during the test or talking to another person, we're not going to turn that on. We're going to use the honor system instead, and we just trust you guys will do your own work. You do have a lot of freedom to grab stuff, look up stuff on the internet. If you learn something during the exam, that's awesome. On the other hand, it's timed. You probably won't have time to look up more than one question. So I would highly recommend making sure that you are ready. The other thing we can do to get ready is take a look at the schedule page. Syllabus, and check out Swaggert's automate the boring stuff. That's the other reading. We'll be pulling a lot of stuff later on in the semester, but he has the first 3 chapters of his book, Python Basics, Flow Control, and Functions, go over a lot of the same things that we are talking about. We assigned readings from Downey's book. Those are good. This is just a different perspective on those same topics. It doesn't introduce anything new. It kind of duplicates what's there before. So if you've already done the reading from Downey and you're looking for just another quick review, but it's not the exact same wording, this would be a great source to go to. All right, guys. So with that in mind, I'm going to go ahead and jump back into the lecture with iteration 2. All right, I hope you guys enjoyed watching Mina's lecture. I apologize I wasn't able to be there for the last 3 days, the last 3 lectures. I went ahead and watched those lectures myself, so I think I could just pick up right where she left off and not have any kind of break in continuity for you guys. But today we're going to be going over a number of new things. We've talked about expressions and variables. We talked about conditionals and functions. We started going over loops. Today we're going to be looking at some things that I would refer to as advanced iteration, including break and continue. And there's a ton of ways to combine all these things we've learned so far, the expressions and variables, conditionals, functions. And what we're going to look at is some of the very common patterns. There's a lot of ways to combine these. But programmers in general stick to some very simple patterns. And understanding those patterns can make it a lot easier to read someone else's code, particularly if they actually stick to the common patterns. So we've seen design patterns in lots of other fields. They're very common. The example that jumps to my mind is like the mechanical engineering design process for making a part. But not everyone's familiar with that. Most people here took English composition or composition in another language sometime during high school. So this is pretty common to see a description of the 5-paragraph essay. So I think this example works more universally. But the 5-paragraph essay has 5 paragraphs. There's an introductory paragraph, 3 body paragraphs, and a conclusion. And people who are familiar with this 5-paragraph essay format, particularly people who teach this stuff and grade your work, they may not necessarily read your essay in order. They might start with the introduction to find your thesis. They may go to your conclusion, read that second to see, where you're trying to go with your essay. And then they might look at the body paragraphs to see that they're actually developing your thesis toward reaching that conclusion. So those are all like a pretty common example. And the same happens with code. People who are familiar with code and people who write code don't necessarily write it line by line in the order that it executes. We follow certain patterns. All right, so here's an example of the very first design pattern. And one way we can think about it is that we can just walk through the code in order and think about what's happening. This is never a bad option. It's called tracing. We use it frequently when we go through things like Python Tutor and talk about the sequential in-order execution. So in this case, the very first thing that happens is line 1. We declare a variable I. We assign it the value 1. All right, there we go. I've got a little box up here where I'm keeping track of my variables, and I currently have the value 1. Then we go into the while loop. We see that while I is less than 30, we're going to do, I'll create a new variable n is equal to I plus 2. So I've got a new box for n up here. Assign the value I plus 2. I is 1 times 2 gives us 2. And we print it out. So now I've got an output box over here. We've just printed 2. And then we increment I. So I becomes 1 plus 2. We'll get that up there and store the new value of I. Then we'll go back through the loop. We say I is it less than or equal to 30? 2 is indeed less than or equal to 30. So we jump into the loop. And we have n is equal to I times 2 again. That will give us 4. We print it out. It's in the output box. And then we'll increment I. So that becomes 3. So I'll cross off the 2, put in a 3 right there. And then continue. While I is less than or equal to 33 is indeed less than 30. We'll go through. And you can do that forever. I'm not going to do that 30 times. The idea here is that while that's great, we can go through in order, but knowing that a certain piece of code is written using a common pattern, we can look at it as a different way to break this down. So experienced programmers will first look for a couple things. They'll look for the loop variable. So in this case, we've got the loop condition right here. So number 1, loop condition. So I'll find the while statement. We see while I is less than or equal to 30. Number 2, identify the loop variable. In this case, this is an I. All right. Number 3, find all the places where I changes. So something where I equals or I plus equals or I minus equals. So in this case, this is the assignment. I starts out at 1. And then down here at the bottom, we see I is incremented and goes up. In the loop condition here, we see that it goes up to 30. So our loop is going to run with values of I equals 1, 2, 3, 4, up to 30. All right. And then this highlighted section, this is the piece that's actually using I. It doesn't change right here, so I don't highlight that when I talk about when I changes. This is just using it. So this is, I don't know, I'm going to call it the sandwich. It's sandwiched inside the while loop. Here's the declaration of the while loop. I've got my colon here. This whole thing, all 3 lines, would be the block. So it's not technically a block, but this is the part that uses I. It's sandwiched between the while loop and the increment. So what we can do is just sort of, I guess, step 4 would be to unroll this and look at what happens if we put in a 1 here, then a 2 here, and a 3 here. So it's a little bit different way of thinking about things. So, I got my slide for this. Unrolling. So we put in a 1, we put in a 2, put in a 3. And these 2 lines, we can think about this as though it's just unrolled like this. Let's see, it goes through the loop 30 times. I've got 2 lines here. This could be 60 lines of more or less copy-pasted code. And that's how I'm going to think about this as I go through and think about what happens. It means I don't need to trace through every single line to decide what's printed. It's going to print 2, then 4, then 6, and I can recognize that pattern. Okay, this is a pretty simple example, but it lets me figure out what's going to happen much more quickly than if I have to trace through the code. So here is the general design pattern for doing something n times. In this case, n was 30. So here's my loop declaration. It has the variable I in it. So I need to be declaring I before I use the loop. I'm going to have the details of whatever I want to happen 30 times or n times here. And then the bottom line is going to be the other piece of bread on my sandwich, the I plus equals 1, the increment. All right. Now check this out. We're going 30 times here. We can either start at 1 and use less than or equal. This is actually a lot more common to start with 0 and go up through I less than n. And a lot of that's because if we have a list of things in Python, oftentimes the index will start with 0. So this one's actually more common. So in this case, 1, 2, 3, 4, up to n. It actually includes the n, or like the 30 in that last example. Or we could see 0, 1, 2, 3, up through n minus 1. So in a list of 30 things, the last one would be number 29, because it would have a number 0 element. All right, the second design pattern is very similar. In this case, we're going to be looking at just doing something with all of the data in the set. In this case, we probably know that there are n items in my data set. There are 50 states in the United States. So if I have some data in a table about all of the states and I'm looking to just add up the population, I can go and I can get row 0 from the table, and then row 1 from the table for California, and then row 2 for Minnesota. I can go ahead and add up all those. So the specifics of adding up the populations of all the states would go here. For a data table like this, I would likely have a function that tells me get the population of state 0, get the population of state 1. And we just put in the specifics here. So I'd have a sum equals 0, and then I would just go through sum plus equals population of each state. So the idea here is I want to do something with all of the pieces of data. So I would have a function count rows, and I would put that right here instead of n. That would tell me how many states we have. And I went, it would be generic or universal for all kinds of tables like this. Frequently, people who write modules will include a function like size of the table, get the rows, number of rows. And then we would have a function that grabs the population for each of the rows, and we would take that index. So here we go. Those count rows functions get right here where n is. And then my population gets placed right here, get the population, and do whatever I want with it. I could be looking for the biggest one. I could be adding them up, find the smallest one, something like that. Whatever I want to do goes right there. And when we have a table, again, we're going to assume that the first row begins at 0 because that's how most tables are stored in Python. So that's why I equals 0 to I is less than, far more common. All right, and design pattern number 3, also very, very similar. So we're going to just do something until we get to the end of the data. This one might not necessarily have that bottom piece of bread on the sandwich, the I plus equals 1, the increment step. But a lot of times programmers who write modules that are used by other programmers will use this kind of structure. Their module will have 2 functions, one of which that just says, is there more data? And this could be written like this because we don't necessarily know how big the table is, if it's designed to work with a generic table, or if it's a function that's designed to work with user input where we don't know how much data there is even after from the table. So it'll have a function that just says has more. This function is going to return a Boolean value, either true or false, so I can just stick it right here as my loop condition. This just needs to be something that evaluates to true or false. And then the function or the module will also have a get next, so I can just grab the next piece of data. This could be a function that asks the user for a number, or it could be using a generic table and just says, okay, get the next piece of data from the table. And inside the module, get next will keep track of which row of the table I'm on. So it takes care of that I plus equals 1 for me. This is another very common design pattern that just goes through the entire set of data. All right, next up, I want to jump over and take a look at the worksheet available on today's website, or the schedule for today. Let me scroll down. We are on iteration 2. Link to the worksheet is right here. Let me go ahead and pull this up. So go ahead, if you haven't pulled up the worksheet already, if you're watching the live stream or if you're just watching the video on your own, pause and go grab this worksheet. What I want you guys to do is figure out what's going on, what is being output. So go ahead and just do the first problem on your own. During the live stream, I'll pause right here for 1 minute. Otherwise, pause the video yourself. And then I'll go ahead and do problems 1 and 2 right now. Then we'll come back and we'll talk about break before moving on and doing problem 3. Okay, so let's take a look at problem 1 and think about those 4 steps. The first thing I'm going to do when I'm looking at this, I'm going to consider finding the loop condition, the top piece of bread in my sandwich. So, and that's right here, while countdown is greater than 1. Step 2 was to identify the loop condition variable, countdown. And then I'm going to find all the lines where a countdown changes. Not just where it's used, but changed. So I see it's initialized before the loop, very important, going to start out at 5. And in the very last line, we're going to see that it's decremented. So it's going to start at 5, we take away 1, it's 4, 3. As long as it's greater than 1, we're going to continue decrementing and doing whatever's in the loop. So when it gets to 2, 2 is greater than 1. When I get to 1, 1 is not strictly greater than 1, so that's going to evaluate to false, and we will skip the loop. So 5, 4, 3, 2. And then when I check out the meat of the sandwich, not technically a block, I don't have a better word for this, but we're just going to be printing it out. So when I think about the output, it's just going to be 5, 4, 3, 2. So pretty straightforward, but I wanted to do an example that definitely just shows the structure. All right, let's take a look at the second example now. All right, as we start taking a look at this, at problem 2, this has loops inside of loops. So experienced programmers are going to find all of the word while to begin with. So we have while I is less than or equal to 3, and here we have an interior loop, inside loop, while j is less than or equal to I. So I've got a double loop here. So I'm going to take a look at the very outermost loop, the one that's to the left. So the block that's inside this goes from here, this line j equals 1, down to the bottom piece of bread in this top outermost sandwich, the I plus equals 1. And this is the whole thing that's going to be controlled while, from this top while. All right, the second while loop is the one that's got j as the control variable. It's just 2 lines in the block here. We've got the sandwich with the while statement. We've got the j plus equals 1, that increment. And the meat of the sandwich here is just print I. So in this first case, we've got 1, 2, 3, 4, 5 lines in the meat of the sandwich, and just 1 line here. So I'm going to go through and think about the outermost loop first, and I'm going to work my way in as I go through things that have more than one nested loop. So in this case, let's take a look. Step 1. identify the loop control, the while statement. So right here, while I is less than or equal to 3. Step 2, I is the variable that we're going to be using to control the loop control variable. So now I'm going to find all the places where that's changed. Here we go, I equals 1, where it's initialized at the very top, and down here, I plus equals 1. All right, I is used a bunch of other places, like right here and right here, but in those two lines, it's not changed. So I don't care about those right now. I just want to know where it's changed. All right, and then step 3, where it's changed. Step 4 is going to be the meat of the sandwich. So all of these things. And I'm just going to consider what happens as I go through. So I'm going to just make a list of the values of I. It starts out at 1. Well, we see here we're incrementing by 1, so it's going to go 1, 2, 3, 4, 5. Okay, but we're going to stop when I is less than or equal to 3. So that means we're only going to be getting the values 1, 2, and 3. And then when it gets to 4, right here, we'll jump out of the loop. This will evaluate to false. After I do that, what I'm going to do is take this inside sandwich, from the line j equals 1 down to this print end. That's the meat of the sandwich. This is what I'm going to unroll. This piece right here, those 5 lines, happens exactly 3 times. And I can just think about grabbing this, copying it, pasting it, pasting it, pasting it. So I've got 3 different copies of it. The first copy, I is going to be 1 the whole time through that loop. So I can just take this I and mentally replace it with a 1. That I can mentally replace it with a 1. In that second pasted sandwich meat, I can replace it with I equals 2. I equals 2. All right, now I'm going to take a look at this. Step 1, find the while statement. I can see that the loop condition variable here is j. So all the places where j changes, up here it starts out at 1 in the initialization line. We've got an increment, so it's going to go from 1, 2, 3, 4. Now, in that very first pasted sandwich meat, j is going to start out at 1, and while it's less than or equal to I equals 1, then we're going to go through the loop. So it'll be j equals 1. Right here it increments to 2, and this will evaluate to false. So it'll jump out of the loop, this loop, and go ahead with the outermost loop and finish up the stuff in this block right there. All right, then I've got a second pasted version where I is equal to 2. J is going to start out at 1 again. I reinitialize j. Then I'm going to go through. J is going to be 1, 2, 3. When I get to 3, it's not less than or equal to 2, so that's going to be false. So all I get is 1 and 2. There we go. Let me just bring this up. Then it's going to go through in that third pasted loop here for the outermost loop. I is going to be equal to 3. So j is going to start out at 1 as long as it's less than or equal to 3. Remember, I can just replace this, just delete that I, put in a 3 in my third pasted block when I unroll the loop. And so j is going to be 1, 2, and 3. When it gets to 4, it's not less than or equal to 3, so it's going to stop. So these are my values of I and j every time I go through this innermost loop. So what I find here is that I'm going to be printing out I, not j, I. It goes through this entire loop, well, once, then twice, then 3 more times. That's 6 times total, and prints out I on every time. The first time through, we'll have I is equal to 1. The second time through, I is going to be equal to 2, and then 2 again, because we'll do it twice. The third pasted block, we do 3 times, so I is going to be 3, then 3, then 3. Now check this out too. We're also printing something in the outermost loop block. So it's going to go through and print out I is equal to 1. Then that loop is done, this innermost loop. And then it's going to print out the word end. Then it's going to go through. I is going to be incremented to 2. We'll have twice through that second pasted block. We'll print out 2 and then 2 again. Then we'll print end. That's the end of the innermost loop. So prints end. Then the third time through, I is equal to 3. We'll do it 3 times. We're just counting up on j. This is doing something n times. In this case, n is changing. So that's the pattern here. We printed out 3, 3, 3. And then we'll print end. So the output looks like this. We have 1, 1, because we're printing I, then end. Then we print it out twice, because this is a do it n times kind of loop. Then we print out end from that outermost loop. If this were tabbed over one more, then it would be inside the innermost loop. We print 1 end, 2 end, 2 end, 3 end, 3 end. But it's tabbed over into this block, so it doesn't happen inside this loop. If you guys have any questions about this, if you're watching the live stream, post them in chat. Otherwise, go to Piazza, post your questions about this. And I'm going to move on and just assume this is making sense. I hope it is. I really can't tell when I'm recording a video. Not the best way. I'd love to be live again. All right, let's go ahead. We're going to talk about break real quick. So our basic control flow for iteration, the while loop, has a structure that looks like this. So we're going to begin here with while and some sort of condition. If this condition evaluates to true, then we do whatever is in the block. And that's everything from the colon all the way down through the end of the indentation. That's a block. Could be many lines of code, could have other loops nested in there. Whatever, it doesn't matter for this block. I'm just going to find the colon and work all the way down. If the condition evaluates to false, then we jump to the code after the loop and we don't execute any of these lines. And when we get to the bottom of the block, we jump back up and check the condition again. So that hopefully there's something inside this block that changes the condition. Otherwise, we'll have an infinite loop. Now, break is going to be a way to change that control flow. It's going to immediately jump out of the loop. So we'll see the structure for break almost always has if with some sort of other condition followed by break. That break skips everything after it. It's just done and it exits the loop. So it adds an extra arrow, an extra way to get out. You can think of it a lot like this condition. It's going to be a different condition, most certainly. Otherwise, we would have just jumped out of the loop right here. But break, final answer, it's a lot like return. Just gets out of the loop, stops executing this, stops the iteration, jumps to immediately after. All right, I want to talk about places where this is commonly used. Number one thing that jumps to mind is where I've got a list of data. This is data programming. When I'm searching for something in the list. What if I'm looking for a state that begins with the letter I? I can go through my list of states until I find one, and I can stop as soon as I get there. Or if I'm looking for a state with a population greater than 20 million, I can go through my list of populations, find one, and as soon as I find the one I want, I'm done. I don't need to continue searching through the list of states. So I'm going to go ahead and do a quick example where I'm using this. In this case, we're going to go back to the prime numbers. So Mina wrote a function at the end of last class where we were trying to decide if a number is prime. I'm going to go grab that code and then bring it up into Jupyter Notebook, and we'll go through and we'll actually write a program that searches a range of numbers and just decides whether it contains a prime number or not. So, for example, this sequence right here, 10, 11, 12 through 17, actually contains 3 prime numbers. So 11, 13, 17. Now, as soon as I find a prime number, as soon as I get to 11, I don't need to keep searching anymore. So I can immediately say true. This contains a prime number. So this is a great example of using break. If I'm looking for a sequence like 14, 15, 16, I'm going to check the 14, say no, 15, no, 16, no. And I do have to check everything in this 14, 15, 16 sequence because I don't find a prime number. All right, let me go ahead and pull up Jupyter Notebook and go ahead and write this code. All right, so I have a brand new Jupyter Notebook pulled up. I've already saved it main. It's in my working directory for lecture 11. And I've copied and pasted in my code. You could ignore this top part. The only thing this code does is makes the width 100% of the screen. So it gives me more space to work in. If you're working at home, you can copy and paste it if you want, but there's no need for that line. The next thing I'm going to do is I'm going to go back. Under iteration 1, we have all the code that Mina wrote. I'm going to go ahead and click there. Here's the demo she did. I'm going to pull up the code for that demo. And it's great. I can just take a look at this because Jupyter Notebook files are HTML. When I look at this, it's already in HTML mode. I'm just going to go down and find her function that finds prime numbers right here. I'm going to copy and paste this into the second cell right here. All right, when I run this block, it's now, I just did Shift Enter to bring this up. I now have defined the function is prime. Now, Mina's great. But let's just go ahead and test this a couple times to make sure that it's working as we expect. So I'm sorry, is prime 14? We'll run that. False, it's not. What if we do 15? Also false. 16. So that was that interior range. Let's try some of the ones that we know to be prime, like 11, 13, true, 17. Okay, so that's looking good. It looks like it works. If you don't remember how this function operates, go ahead and go back, watch Mina's third video, and review. All right, I'm going to go ahead and take a look at that example problem next. And I'm going to write a function. Let's just call it range has prime. All right, because we're going to be looking at a range of numbers from some starting number to some ending number, we're going to need two parameters and all of my function definitions in a colon. Jupyter knows I'm defining a function. It already tabs over for me, so that's awesome. Let's just go ahead and make sure this is working, that something's happening. So I'm just going to print out start and end, and then go ahead and try calling this function. We'll go ahead and range as prime, and we'll go ahead and give it 10 to 18. All right, and right now all we're going to do is print those things out. That's not what we want in the end. We're going to actually want to go ahead and see if it has a prime number. So we're going to go ahead and test all of these numbers inside that range. So as we go through, I'm going to need a counter variable. I've been using I the whole time. I'm just going to keep it as I. Next thing, we need the while statement. While, in this case, I is less than something. And then inside that, let me add the colon so Jupyter will tab for me. I'm going to have my sandwich meat, where I'm going to do something. Maybe that's a better way to put it for the example. Do something. And then I've got that iteration. So I'm going to be going all the way up to the end block. So I plus equals 1. All right, let's fill in some of these question marks, and then we'll just make sure that things look good. So I is actually going to start out at my start. Next thing, I need to know how far I goes up to. So we're going to go all the way up until it's equal to end. But we want to include end. It'll stop one number too soon if I do it like this. So I'm going to go ahead and add the equals here. Well, I is less than or equal to end. I want to do something. All right, just to make sure this is working, first thing I'm going to do is just print out I and make sure I'm getting my numbers, in this case 10 through 18. Let me go ahead and run this. So I still have that first line that prints out the range. And then I've got all these numbers here, 10 through 18. All right, let's upgrade this even a little further. Instead of printing out just I want to do something. So I'm going to say I'm just going to abbreviate this because my function is actually called is prime. I'm going to call is prime. We'll stick it in that variable, and we'll just give it I because it's going to go through each time. So now I'm printing out I, and I'm going to print out is p. And that should be a list of trues and falses. We can make sure this is working here. So 10 is going to be false. Awesome. 10 is not prime. 11 is prime. Can't divide it by anything and still get a remainder with 0. Okay. So anyway, it looks like it's working. Time numbers were 11, 13, and 17 in that range. All right, the next thing I want to take a look at is I don't actually need to do all of this stuff to decide if something is prime or not. What I really need to do is keep track of prime number found. Okay, awesome. Right now, at this point, I haven't found a prime number. So I'm just going to start this out at false. Sound good? All right, and then if I find a prime number, in that case, so I've got is p, is it prime or not? That's a Boolean. So I can just say that if is p, it'll be true or false. I can go ahead and say prime found equals true. And then at the very end of this, I can return, oops, I meant right here, return is prime. So I've just added 3 pieces here. This is another really common pattern. If I'm searching for something, in this case I'm searching for a prime number, I'm going to start it out as I didn't find one. The moment I do find one, upgrade this to true, and then return this at the end. So another design pattern for finding. It could be finding the biggest something. We'll keep track of the biggest one found. It could be keeping track of just is it there or not. All right, so let's go ahead and run this. And we'll go ahead and print. Here, we'll do found equals that. That'll store that in a variable. And we'll print out found. All right, so that didn't work. I actually have two typos here. First up, I'm using the variable prime found, and I spelled it wrong here, and then I didn't return the right thing. I needed to return prime found, not the name of the function. All right, let me run this again, and now it looks like it's working. Now it's not working. Check that out. So it started out at false. It never got upgraded to true. Let me take a look at this and see if I can figure out what I did wrong. Found it. That took me way too long to spot. Okay, guys, so the mistake is right here inside my while loop. I'm actually returning is prime found the moment I go through the very first iteration loop, because this is inside the while loop. So I starts out at 10. Is it prime? No, that's false. If it's false, it skips this. We print it out. That's the 10 false. Increment, it's now I is 11, but we return the false immediately. To fix that, I need to add one more tab. So what as I went through this? That was called tracing. I just sort of went through what is really going on when I recognized that it was returning the value for 10 and not checking everything in the loop. That was the moment, the aha moment for me. All right, let's try this one more time. There we go. Check this out. Now it's going through all the items in the list. It's going through false, true, false, true. The moment it gets to this 11, though, it's identified that it's found a prime. I no longer need to check all the rest of these numbers. So what I'm going to do is go through, upgrade this. The moment I get here, I found the prime, I can break out of this loop. That will jump out of the while loop right here. This is the block. It's going to skip to the very next line, which is return prime found. If we never find one, this value will still be false. But because it's upgraded right here to true, we no longer need to check everything else. So let me just run this real quick. You can see I do the 10, it's false. I don't actually print this out until after my condition where it jumps out. Let me move this up. So we go through, 10 was false, 11 is true. When it's true, we're in here. Prime found becomes true, we break and return that value. All right, let's jump back over to the worksheet and just sort of walk through an example with break. This is problem 3. So I'm going to go through these very first, step 1, find the loop. So while loop is right here, while num is less than 500. Step 2, find the loop control variable, that's num, and look for all the places where it's changed. In this case, it starts out at 0, and then right here, we're plus equaling, that's an assignment. So we assign num plus 100. Now check this out. It's not the sandwich structure we've seen before. This is a different design pattern, but it's still a design pattern. It's just that we're incrementing as the very first thing, and then the meat of the sandwich comes after that. So let's go through and think about the loop control variable. What values does it take? It's going to start out at 0, then be 100, 200, 300. So these are the values it's going to take up here as we do all of our checking. All right, when we get here, when num plus equals and gives us, 0, 100, 200, 300, 400, 500, this next time through the loop, it's not going to run. Now, inside the sandwich meat of the loop, we are using num twice in this case, but we're not changing it. But it increments first. So inside the loop, inside the sandwich here, when we get to that print statement, the values it takes on are actually 100, 200, 300, 400, and 500. So using this kind of design pattern adds an extra step in my brain while I have to go through and think about it. I like the very first design pattern we talked about best, where the increment happens last. It makes it easier for me to think about it. This kind of design pattern is a little bit more difficult for me to think about what's going on. So as you guys are writing homework questions, you can use either one. They both work. In fact, there's hundreds of ways to combine all these things together so that it gives us valid answers. But some of the patterns are easier to work with than others. All right, so let's talk about output now. The inside of this sandwich meat right here, the print statement, is going to first print out the number, turns it into a string, so I can use the string concatenation with the question mark. So the first time through the loop, first time through the sandwich here, I will be 100. So it's going to print out 100 with a question mark. Then if num equals 300, it doesn't, so skip that. Print yes. So we got the 100 question mark, it's going to print yes. Next time through, it takes on a value of 200, so it's going to print out the 200 with a question mark. Is it exactly 300? No, skip that, print yes. Next time through, the value is 300 as we go through the sandwich. It's going to print out 300 with a question mark. Then it's going to ask if 300 is exactly equal to 300. Yes, it is. That's true. Do what's in here. Break. That's going to skip outside of this block. So here's the block. It's going to jump all the way. There's no statement here, so the program is just going to end. And the output's going to look like this. 100, yes. 200, yes. 300. Don't print the yes. We skipped it because of that break. Just final answer, done with the loop. Skip all the way out of this. All right, so next up, I want to talk about the continue statement. It's a lot like break. It gives us a way to change the control flow within a loop, but it's a lot less aggressive. We don't just stop and end immediately. We go back to the top of the loop instead of jumping out of the loop. So it's going to look something like this. Here I've got my basic control diagram for a loop. We've got the loop condition. If it's true, we do what's in the block. If it's false, we're going to skip all the way to the end. At the end of the block, we go back up and check the condition, and we just go through until the condition is false. If we add the continue statement, it's going to look, design pattern for the continue statement says if something, then we're going to continue. By continue, it means continue with the loop. So we'll jump back up to the top of the loop and check the condition. And we skip the code that happens after the continue. Now I had a very similar picture with break. The break had the arrow that went down here to code after the loop. Continue makes one little change. It makes the arrow go back up and checks the condition again. And it's going to go through the loop if that condition is true, potentially many more times. If the condition here is false on the next time, it skips the continue and it'll do the more code. So a great place where we want to use this, an example that I'm going to do in my next demonstration is to skip over values that are outside of the range, out of bounds. So if we're going through and looking at scores, if a score has to be in the range 0 to 100, if someone enters 100 million for their score, we want to skip that. So this is just going to be computing the average score. And we'll just keep a running average of scores that a user provides. So I'm going to go ahead and use idle for this demonstration. If you haven't pulled it up yet while I'm rambling on about the example, you can pull that up. And I like idle. I know you guys don't like switching between Jupyter and idle, so we're trying to get through the lecture. It makes it more tools to keep track of. But I really do like idle for user-provided input. I think it gives us a better way to do that than Jupyter. So that's why I'm switching. I do have a reason. All right, so our couple other details. The input is going to accept the letter Q, so we can quit, and we'll keep running until we get to that Q. And we're going to recompute the average every single time the user enters a number. I've got an example here. If they put in something outside of bounds, 110, we'll print out bad input, skipping. I probably won't remember it exactly, but I'll get something along those lines. All right, I'm just going to go ahead and go up to my Jupyter notebook. I'm going to save this. Save and checkpoint. There we go. And now I can go back over to PowerShell. I can Control-C to quit this. That'll exit Jupyter Notebook. Probably give me an error message when I pop back over here. That's fine. Connection ended. But what I want to do now is in this same directory, we'll go type idle, and then we'll give it a name of a file. If you guys are on a Mac, you'll probably need to type idle3. Let's see. We'll call it avscore.py. All right, that's going to open up idle for me in just a second. Here we go. All right, let's go ahead and just start off with an infinite loop. We don't know how many pieces of data or how many scores the user is going to input. So let's go ahead and while true. That's going to give me an infinite loop. This will always evaluate to true. I can stick in anything I want here. That evaluates to a Boolean. True definitely evaluates to a Boolean. All right, the next thing I need to do is I need to get some input from the user. So x equals input. Let's help them out. We'll tell them enter a score. That needs to be between 0 and 100. So let's just remind them right there. 0 to 100. And then or Q to quit. There we go. So then they're going to give us a value. They're going to put it in x. Let's just go ahead and print it out. X equals comma x. There we go. This will just give us a way to make sure this is really working. All right, so let's see here. I'm going to click run and remind myself that the running the module is just F5. So if I do F5, there we go. It gives us a second window. Let me just arrange these real quick so we can see everything. there we go, looking good. Okay, so enter a score. Let's try for x equals 4. That I don't like the way that looks. I want a space right there, maybe even a colon. All right, that will come up looking better next time. Enter another number. We'll throw in a 10. Looks good. We'll give it a Q. All right, we didn't actually quit. So let's go ahead and add that piece next. I'm going to jump back over here. Instead of just printing it out, what I really want to do is say if x exactly equals the number q, or the letter q, then we're going to do a couple things. We'll print out exiting, and we will break. That'll get us out of this loop. So let's just go ahead and test this and make sure that this works. So again, I'm going to kill this. I'm going to go back over here. I'm going to push F5 to run it. Enter a score, Q to quit. So 10 just prints it out. Q quits. All right, excellent. Looks like that piece is working. All right, next up, I'm going to have them entering a bunch of scores. So let's go ahead and do a couple things. I want to keep track of the average. So average equals, we'll start it out at 0. The problem with this is it's really hard to just think about computing the average and getting it updated. The average is going to be the total divided by the number we have. So in fact, let's do that. We'll just keep track of the total, start it off at 0, and the number of entries we have. That's going to start out at 0 also. And I'm not going to bother trying to keep track of this. We'll just compute it every time we need it. All right, next up. So if the user actually enters a number, we're going to need to turn that into a number. So x is equal to int x. All right. Once we do that, because input always returns a string, important to remember that when you're taking the exam, input always returns a string. If you don't remember, this will just give you an error when we try and add up the numbers. So turn this into an integer. Then we're going to be adding that number to the total. Total plus equals x. And we have the number of entries plus equal, we just entered one more. All right, now at the end of every time we go through this loop, what I would like to do is go ahead and add their score in, or print out the total. That's what I really mean. Print, we'll just say average equals, and then we will compute the average. Let's see, that's total divided by number. All right, I'm going to go through and just test this much. So right here, F5 to run. It's going to give me the restart. And let's put in 10. All right, the average is 10. Let's give it another 10. Right now I've got an average of 10. If we put in, let's see, what's something? We're going to have three numbers. I've got a 10 and 10. My total is 20. Let's put in 40. I can't see that. All right, there we go. Let's put in 40. Run that. Now I've got a total of 60. I've got 3 entries. The average should be 20. All right, it looks like this is working. All right. And then some person who's not paying attention enters their score at 100 million. And all of a sudden we have an average that is way out of bounds. And it's really hard to recover from that. So what I want to do is ignore all of these inputs that are outside of the right range. So I'm going to push Q to quit. I'll get back over here. I'll pop that screen back up like that. Let's see, where's idle? Here we go. Looking good. What I want to do now is skip all of the bad values. So right here, instead of putting them in the total and the number, I want to just go back up to the top of the loop. So I'm going to say if x is less than 0 or x is greater than 100, and we'll go ahead and use the inclusive version. So if they put in 100, it's still going to work. Colon, end that up. We will just continue. And I believe we said something like print out bad value. And we'll remind the user that this needs to be between 0 and 100. I don't remember exactly what it said on that demo slide, but this is it gets the idea across. And we'll make that capitalized too. And capitalize everything else. No, it looks good. Let's test this out and make sure it works. So we'll go ahead, we'll restart this. We'll make that big. All right, enter a number. So we tried 10, 10, we tried 40. So that looks good. The average is 10, average is 10. 40 gives me a total of 60. Divided by 3. Let's go ahead and try 100 million. It's going to tell me bad value. All right, now I had an average of 20. Let's throw in another 20 and just make sure that we have an average that's still 20. All right, awesome, looking good. Then if we've got 20, 20, or 10, 10, 20, 20, that's a total of 80. If I stick in another 80, I've got 160. That's going to give me, 80 was the wrong choice to get something easy compute. 160 divided by 5 looks like, 32. All right, so it looks like it's working. Q to quit. I'm going to jump back over to the worksheet and do one final walkthrough. 1 second while I set that up. All right, so here we are looking at the problem number 4, the continued one. If this video is rambling on too long, I'm just going to stop it during the live stream. You guys at home can continue watching. And go ahead and do those problems on your own. All of these problems are available on the interactive exercises on the webpage. You can get there from the link. So go ahead and walk through these after you think about them. And this might be a little cleaner way to just do the tracing because it'll go through one step at a time. But the point of I want to talk about the patterns that we see. So the Python tutor examples are not going to give us this. They're going to do the step-by-step. Not a bad way, but this might be a little more efficient for us to think about it. All right, this is the exact same demo we had a moment ago with the break statement. The only difference is we put continue in here. So we're going to see that num goes from 0 to 400. The increment is first. So in the sandwich meat of my while loop, I'm actually going to have already incremented it. So it's going to give us 100, 200, 300, 400, 500 inside the loop, or inside this block right here with 4 statements. So when we go through and print it out, first it'll print out 100 with a question mark. It's not 300, so we skip down. It'll print yes. Then it'll print 200 with a question mark. That's not 300, so we skip down and print yes. Then it's 300. We print out 300 with a question mark. It's 300 this time, so we will continue. That's going to jump back up, and we will then, number is going to be 400. We'll print out 400 with a question mark. Not 300. Skip that, print yes. Then 500 question mark. Skip that, print yes. So the output's going to look something like this. The only thing that we have skipped with this continue is that yes after the 300. So that's missing right here. All right, guys, I'm going to call this the close to the video. There's one more example. This is while we have nested conditions here. This is just a really good practice problem, particularly for the exam. Go ahead, do this one on your own. I feel like the video is probably more than 50 minutes at this point. So go ahead, do this one on your own. And you can walk through it on Python Tutor, but think about that design pattern before you go look at the final answer. So just a quick preview. We have multiple while loops right here with this continue condition on the inside. So go ahead and investigate what happens when we put a continue in here. I'll tell you a secret right now. It's only continuing out of the innermost loop, but go ahead and verify this for yourself. When we hit this continue, it's going to jump back up to this condition. Not that one. And again, I've got this design pattern where my if condition with the continue, this is inside an if block. So this is almost always how it's used. We'll rarely see continue outside of a conditional statement, like an if statement. And when we hit this, it's going to jump back up to the innermost while loop. All right, guys, have a great day, and I will see you soon.